Hello. Today we're going to learn about extremas. So in this section, I will go over the difference between a relative extrema, uh, local min or and local max, and an absolute extrema, absolute max, and absolute min. And then I will show you how to find, and then I will show you how to find them. So yeah. So what are extremas? Extremas are either relative max, or relative min, or we call it um, local min, local max, the same thing. So why do they call it a relative min versus an absolute min? Well, with relative mins, there's no boundary. So that's like a big clue. Um, so if you look at this graph, f of x equals x cubed minus 3x squared, notice it's a polynomial that keeps on going up, 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 and then down, down here, keeps on going down there. So there's no stop boundaries. So that's why this is one of the lower points of the polynomial. It's not the lowest because this keeps on going down to negative infinity. So this is one of the lowest. So that's why they call it relative min. And then over here, 0, 0 is a relative max. It's not the highest point because this keeps on going up. So yeah, that's your relative max. So that's pretty much the difference between a relative max and relative mins. It's a relative since it's not the lowest or the highest point in the graph. How do you find it? So how do you find your relative min and your relative max? Well, first, step one says find critical points by taking first derivative and setting it to 0, and then solving for x. Step 2 says make a line chart similar to test point method. And step 3 says if the line chart goes from positive to negative, you can have a relative max. If it ends up as negative to positive, you have a local max at that specific value. So step 4 says to find the y value of the relative max or relative min by plugging x value back into the original equation. So let's do an example. So let's say we had f of x equals x cubed minus 3x squared. And how did they get the relative min of 2, -4, and then a relative max of 0, 0? So step 1 says we got to find the critical values by taking the first derivative and setting it to 0 and solving for x. So let's do that. So if our function is f of x equals to x cubed minus 3x squared, let's take the first derivative. So that would be 3x squared minus 6x. Okay, then what we're going to do is set this whole thing to 0. Let's see. So what I could do is take out a 3, and we can also take out an x. So this would be x minus 2 equals to 0. And if you set each equation to 0, divide this by 3, I get x equals to 0. And then over here, you're going to add 2, I get x equals to 2. So these are your critical points. So just like in college algebra, we do a test point method. It's the same thing. So our smallest x value is 0. Our higher x value is 2. So we're going to test 1, 2, 3 boundaries. A number less than 0, a number less between 0 and 2, and boundary 3 is a number greater than 2. So The only difference is it's f prime. You put your x value in f prime. So if f prime of x is 3x squared minus 6x. Let's test boundary 1. So a number less than 0 would be -1. So this would be 3 times -1 squared minus 6 times -1. So that gives you a +9. Just like the test point method, we don't really care about the number, we care about the sign. So this is positive, so you're going to put a plus. And then let's test boundary 2. A number between 0 and 2, that would be, you could do 1. So I get an output of -3. That's a negative value, so you're going to put a minus. And then a number great, a boundary 3, a number greater than 2, so let's do 3. And that gives you an output of +9. So plus. Okay, so if you look at our line chart, it states that what is it? If you have a sign that goes from positive to negative, you have a relative max or a local max. If you have a sign that goes from negative to positive, you have a local max, uh, local min. Okay, so let's look at our sign. So we have a positive and a negative. So that's a big clue. We have a local max at the x value at x value equals 0, right? So if you look at the sign, positive, negative, that means that we have a local max at this value. And then if you look at the sign here, we have a negative to positive. That means we have a local min at the x value of 2, right? So negative to positive, you have a local min at x value equals 2. Okay, so now a local max and a local min is a coordinate, so you got to find the y value. So to find the y value, you don't put it in the first derivative, you actually put it in the original one. So let's do that. So if our original function is f of x equals to x cubed minus 3x squared, let's find our y value for the local max. So you plug in 0 to the function. So you get 0 cubed minus 3 times 0 squared. That's going to be 0. So that's why our local max or relative max, they're the same thing, is at 0, 0. Now let's plug in the y, let's plug in the x value of 2. And let's see what we get. So we have f of 2. That would be 2 to the third minus 3 times 2 squared. So that would be -4. So that means that you have a local min, because the x value is our local min of 2. We have a local min or relative min, wherever it's the same thing, at 2, -4. So yeah, that's pretty much how you do it. You find your critical points by taking the first derivative, setting it to 0. So once you find your critical points, do the test point method. And then yeah, if the sign goes from positive to negative, you have a local max. And if the sign goes from negative to positive, you have a local min. Okay, now let's talk about absolute extremas. So absolute extrema, absolute max or absolute min is the highest point or the lowest point within a certain boundary. So you could tell that you could tell you can have an absolute extrema if they close it with a certain boundary. So for example, locate the absolute extremas of the function on the closed interval f of x equals negative x squared plus 3x from the boundaries 0 to 3. So these are all x values. This 3 is not a y value. So this is like an x and an x. So if you're curious what that graph looks like, it's a parabola. It would look something like this. So we can only go from 0 to 3. So here's 0 to 3, and it would look like this. It's a parabola, upside down parabola. So it's obviously we only have an absolute max, not an absolute min. Sometimes you'll have both. But we do have an absolute max. Now, how do you find your absolute value? Absolute max. So it's slightly different from the local min and local max. You don't have to do the test point method. What you have to do is just like the local relative min, relative min and relative max. You got to take the first derivative. So f prime of x would be the derivative of negative x squared is negative 2x, and then the derivative of 3x is 3. Set it to 0 and solve for x. So subtract 3 and then solve for x. So you get positive 3/2. Okay, so now you don't have to make the test point method, but instead you make like a table. And you list all your x values. So all our possible x values, well, one of them is 3/2. And then they say that our boundary is from 0 to 3. So 0 to 3 they're all x values. So you're going to put 0 as another x value and 3 as another x value. And then what you're going to do is plug in these x values back into the original function. And then you have an absolute max or absolute min for whatever the y value is. So if you have if you have a very high y, if you only have one high value, you have an absolute max. So let's plug it back in to their not first order, but just regular function. So let's do 0. I think that's the easiest. So plug it back into the original problem. So our original one was original equation was negative x squared plus 3x, right? So if we plug in 0, that would be negative 0 squared plus 3 times 0 would be 0. So you have 0 comes 0. Let's plug in, so this has a y value 0, so then let's plug in 3/2. So that would be negative 3/2 squared plus 3 times 3/2. So negative 3/2 squared, there's no parentheses, so it's going to be negative 9/4 plus 3 times 3, that's 9/2. So you need a common denominator. So the common denominator between 4 and 2 is 4. So this means to multiply top and bottom by 2. So that would be 18. So 18 minus 9 is 9/4. Or that's about, or exactly 2.25. So at 3/2, the y value is 9/4 or 2.25. And then let's plug in what is the y value when the x value is 3. If you plug in 3, you get negative 3 squared plus 3 times 3. So that's like saying negative 9. Yeah, 3 times, this is a 3. So negative 9 and then 3 times 3 is 9, so that's 0. So you'll have a y value of 0. So if you look at all the y value of 2.25, a 0, and a 0, the highest y value is 2.25 or 9/4. So that concludes that you have an absolute absolute max at 3/2, comma 9/4. Okay, so that is relative min, relative max, absolute min, and absolute max, and the critical values. The next section should be learning about where the slope increases and decreases. Okay, so that's it for today. Thank you. Bye-bye.